Hello, welcome to my Pre-Algebra Big Ideas review series. This video covers Chapter 9, Section 3 of your Big Ideas textbook, titled Two-Way Tables. How can you read and make a two-way table? You will be able to answer this question by the end of this video. You will have reviewed recent lessons regarding reading a two-way table and finding marginal frequencies, making two-way tables, and finding relationships within two-way tables. Please leave a like if you find this video to be helpful. Give your classmates a heads up too. It will more than likely help them, and it will certainly help this channel to be seen by more students. If you would like me to cover any of these topics in greater detail, please leave a comment here in this comment section below. I read them and do my best to address each as time permits. Please subscribe to my channel and ring the bell icon to be notified every time I release a new video. Thank you. So let's get into it. Okay, so a key idea here, two-way tables. A two-way table displays two categories of data collected from the same source. For instance, you randomly survey students in your school about their grades on the last test and whether they studied for it. The two-way table shows your results. Each entry in the table is called a joint frequency. So we're going to look at this table here. So here was the students, a column for the students, studied, and here studied and did not study, students. On the other side, they want to know whether they passed or failed. Grades. Students, studied, not studied. Grades, passed, failed. And you fill in the columns here. So we'll find out that under the student column, studied and passed, there were 21 students. 21 students studied and passed. So if you make up this little table knowing that you have two questions from two different types of students, the ones that did or didn't study and whether they passed or not. So you have four possible answers. Did you study? Did you not study? Did you pass? Did you fail? And then you fill them in. So in our case, of the students that studied and passed were 21. The ones that failed, there was one that failed. And that didn't study and passed were 2. And that failed because they didn't study, possibly, were 6. And these entries here are called joint frequencies. So that's kind of how a two-way table works. You have data in one way and data in the other. In this case, it was students studying and not studying, and another one, whether they passed or failed. Okay? Okay, example 1, reading a two-way table. So how many of the students in the survey from above, I brought it into this slide, you can see it right here on the right, from the survey above, studied for the test and passed? It's an interesting question. If you studied, did you pass or not? Well, the answer of that is you look in the entry studied column and passed row. So I look in the studied column because I want to know students that studied and passed. Okay? So I look in the study column and the passed column, a row rather. And I look, and that's right here. So the answer to that is going to be 21. 21 students studied and passed. In the entry from the column, passed right here, 21. So 21 of the students were surveyed, studied for the test, and passed. The sums in the rows of columns of the two-way table are called marginal frequencies. So what they're telling us here now is as we move down, if we want to know the marginal frequencies, we're going to add these together. We're going to add the passed and the failed, and we're going to come up with an area on the bottom here. I'm going to draw it in right now. You can come up with an area down here, so to speak, that you can, and you'll have it on the side too. But for the marginal frequency of the studied students, the answer is going to be 22 because it's 21 plus 1, and this is going to be totals. And we're going to have it on the columns side too. In the next slide, I think we're going to see that. Okay? So again, marginal frequencies are the totals of each row and the totals of each column. And you now know how to read the table because if they wanted to know how many students failed and studied for the test? You say, well, studied, right here again, studied and failed, 1. How many didn't study and passed the test? Oh, 2. 2 studied but passed also, or didn't study and passed. If you didn't study and failed, there were 6 students. So you kind of get the idea. So now, example 1. Find and interpret the marginal frequencies for the survey from above. Create a new column and a new row for the sums, and then add the entries. So what they want you to do now is we've looked at, this is the table here that was from the above. I'm going to see if I can mark it here, and I'll mark it maybe red so it's easier to find. Okay, so the table from above was right up here, right? All of this area here. All right. And it comes right down here. Excuse my squiggly line. I'm not very good at drawing with this pen tablet. Well, I'm not really... Oops, sorry. I got to erase that. I'm not paying attention. Here I am worried about my lines. And I'm not paying attention. Go back over here. I'm going to get this. Go down here to here. And then come across. There. There's the original table. Okay? We had students that studied and didn't study, and students that passed and failed. Okay? So now what they want you to do is to create a new column and a new row for the sums of the entries. So what we've done then is we've taken, I'll change this to blue now. So then we're adding in this row here. And this row covers, it goes over to here. I'm just going to draw just like that. So this one covers the columns. Okay, so this one has the total from the columns. Totals. And totals of the studied, students that studied. 21 plus 1, 21 plus 1 gives you 22 total that studied. That did not study, we have 2 that passed and failed, but we have 2 and 6, 8 right here. 8 that did not study. And then on the other side, we have the column here, which is for the totals of the rows. So now, how many passed? 21 that studied and 2 that did not. But when you add them together, it's 20 plus 2 is 23. Right here, 23. And of the failed grades, you have 1 that studied and 6 that did not, and you have 7. So you total going from left to right, and you total going from top to bottom, with these new columns and rows that you added. And then finally at the very bottom, right down here, I'll draw it in orange, I guess orange. Right down here, this is the total from both ways. So 22 plus 8 is 30, and 23 plus 7 is 30. So now you can tell everything about this table. How many students passed, how many students failed, how many students studied, how many students didn't study, how many students were surveyed completely, okay? You can get that information. And these rows here, the data in these new rows, the total rows here and columns, those are your marginal frequencies. They call them marginal frequencies. Right up here, marginal frequencies for the study, okay? Okay, exercise 1, you're on your own on this one. Directions. You randomly interview students in a cafeteria about their plans for a football game and a school dance. 2-way table, right? 2 things, football games and a dance. And whether or not they what? The 2-way table will show the results. And whether or not they attended or didn't attend. Did they go to the football game or not? Did they go to the dance or not? You see the data here in the table. So it's up to you now to take this on your own. And then when you get back, we will come see if you can come up with the answers and look at these data, maybe and find. And then it says they want you to find and interpret the marginal frequencies too. So you're going to have to do that too. So I'll wait. Okay, now that you've done that, let's go ahead and take a look at this. So how many students will attend the dance and not the football game? So if we go over here to our table, football game, not attend the football game. That's right here, not attend the football game, but attend the dance. Okay? Attending the dance and not attending the football game is going to be 5 students. 5. Five students will attend the dance and not the football game. Okay, find and interpret the marginal frequencies. So let's do that. So let's draw up the table here for the marginal frequencies. I think I'll leave it in blue, I guess. So we're going to draw from right here. I'm going to put down, this is going to be a little tight on the corner here, but you can imagine this line going down here. And it goes all the way down this far. Boy, it's not a very good drawing. Okay, and we're going to go across. Okay, and we're going to go across here, and we're going to go down here. And up here we're going to say total and total. I can put it in here. And then we're going to put a column here and a row here. Okay. So now you've got the table set up. And what do you want to know? What are the marginals? Is find and interpret the marginal frequencies. So finding the marginal frequencies, what do we have here? We have in the column for attended, we have 35 attended and 16 didn't attend. So what is that? That's 51? 51 total, right? Because 35 and 15 is 50 and 1 is 51. So there were 51 attended the football game. And now 25, 5 plus 20, did not attend the football game. And then if we go from left to right here, 51 and 25 is going to be 76. So let's see how that turns out. 76 over here is the total in this column. Remember, they have to be the same. Now going across, 35 and 5 is 40. And 16 and 20 is 36. And 30 and 40 is 70, and 6 is 76. So the totals are the same. And it says, so now we found and we're interpreting it. So what are we going to find out? So we know that what would be an interpretation of the marginal frequency? We know that from the people that attended the game, there were 51 people attended. Whether they went to the dance or not, we don't care. The 51 people attended the game. And 25 did not attend the game. And attending the dance, whether they went to the game or not, we know that 40 people attended the dance and 36 people did not attend the dance. And that totally there were 76 people, right here, 76 surveyed. And that's basically how you read this. Going across, you can say, well, there were 40 attended, and I don't care whether they went to the game or not. But now we've mixed the two data together. So we have football game attended and not, and then we can kind of draw a conclusion maybe from that. We can say that all the people that did not attend the game, maybe only a few attended the dance. So the dance and the football game, maybe they couldn't even go to the school that night, no matter what, right? So there's things you can think about the data and wonder, well, why did that happen? If you attended the football game and the dance, it was 35. It's the largest quantity, 35. Well, maybe the dance was after the football game, right? It was a homecoming football game and a dance following or something like that. So there were people that were at the football game also went to the dance. So you can kind of make some interpretations using this data and the marginal frequencies. So the marginal frequencies, I'm just going to draw an arrow over here, and I've interpreted them vocally. Okay, example 3, making a two-way table. So let's make one. So you randomly survey students between the ages of 12 and 17 about whether they ride the bus to school. The results are shown in the tally sheets. Make a two-way table that includes the marginal frequencies. Okay, so what they've showed you in the tally sheet over here is we've got rides the bus and does not ride the bus. And then they have the age group from 12 to 13, 14 to 15, 16 to 17. Okay, it almost sounds like freshmen, sophomores, and juniors, right? Kind of an age pattern here. And then they said didn't ride the bus, so we have 12 and freshmen, sophomores, and juniors. And then they tallied them off, the tally sheet here, and we can know how many each when they asked the question. They gave a little tick for where the answer was, right? So now we've made a table, and the table looks like the other one, except it doesn't have 2 items in the age group. It has 3 columns. 12 to 13 right here, 14, 15, 16, and 17. Okay, that's totals in here. On the side, these are marginal frequencies. We'll address those in a second. And then the students, they either ride the bus or they didn't ride the bus. So let's do it. So for the students that rode the bus between ages 12 and 13, there were 1, 2, 3, 4, 24. And look at that right here. There's 24 12 to 13-year-olds that ride the bus. And then 14 to 15-year-olds, we have 12, 5, 10, 12. And for the 16 to 17-year-olds, we have 14. Here it is, 14. And now we're going to go down to the don't ride the bus, or does not ride the bus. And we have 16, 12, right here, 16, 12 to 13-year-olds. We have 13, as you see them, 10, 13, 14 to 15-year-olds. And finally, 21, 1, 2, 3, 4, plus 1, 21, 16 and 17-year-olds that don't ride the bus. Now we're going to add the columns. They want to know the marginal, for instance. The 2 categories for the table are the ages and whether they ride the bus, right? Here they are, ages and ride the bus. Use the tally sheets to calculate the joint frequencies. That's what we did here. Joint frequencies are these numbers in the table. And to add and find out the marginal frequencies. So now we're going to add in the column, the row at the bottom here, and the column over here on the side. We're going to add this portion in here. Okay, totals. And now we have that. Okay, so what do we come up with? To find the marginal frequencies, going through the columns. 12 to 13-year-olds, there were 24 and 16. You add them, and that means that there are 40 students aged 12 to 13 that are, whether they ride the bus or not, are being surveyed. You know how many students are being surveyed. 14 to 15-year-olds, there were 12 and 13, makes 25 students. And 16 and 17 makes 14, and 14 and 21 is 35, right here, 35. Students, 16 to 17-year-olds, whether they ride the bus or not, that's what were surveyed. And if you add these up, 25 and 35 and 40, you're going to get 100. Okay? So 25 and 35 is 60 and 40 is 100. And then if you say, now you look at riding the bus, what's the marginal frequencies for kids that ride the bus? So students riding the bus, you have 24 plus 12 plus 14. That equals 50 students ride the bus of any group. It doesn't matter. Whatever their age was, they ride the bus. And how many do not ride the bus? Well, 16 plus 13 plus 21 is 50. So you add them and they both add up to 100 students. So you know your addition is correct. You got the same number. Okay? Good job. Okay, example 4, finding a relationship in a two-way table. So this is interesting. So it says using a two-way table in example 3 above, but it's now down here. I've got it in right here in the on this slide. We've got it right down here. It says organize the results in a two-way table and explain what one of the entries represents. So this is the table we started with from above, and this is the one that's we've created, and it's basically the same table. But now we're going to talk. We're going to first of all, they want us to look at the relationships, and the way to do that is we're going to organize this by finding the percentages in the columns. Okay, so we want to. So what can we find out by looking at the percentages? So what we find out, how do we do the percentages? And we take, in this case, we take let's go with the first ages 12 to 13 column. If we do that, we know that there are 40 right here, 40 students age 12 to 13. So if we take and we do 40, right, and we divide that into, let's say, the number of 12 and 13-year-olds that ride the bus, this 24, okay, we can find that that equals what? That equals 0.6. And if we do the opposite, if we say now the 16 divided by 40 is equal to 0.4. Well, that 0.6 and 0.4 ends up being of 60% and 40%. Okay? So if we do that to every item, so with each column, so for the 14 to 15-year-olds, we get 12 divided by 25 and 13 divided by 25. And in the 16 and 17-year-olds, we get 14 divided by 35, and we get 21 divided by 35, okay? And we'll get the percentages. Okay, and as we do that, then we can now get some information from the percentages. It's interesting because if we look at that, we put the percentages in the columns and rows instead of the numbers of students. So now we have 12 to 13-year-olds, 60% of 12 to 13-year-olds ride the bus. And 40%, right here, 40% do not ride the bus. 48% of the 14 to 15-year-olds ride the bus. And 52% of the 14 to 15-year-olds do not ride the bus. And the same thing for the 16 and 17-year-olds, 40% do not ride the bus. And 40% do ride the bus, and 60% do not. So that's very interesting because now we can get some different information out of it. When you look at the numbers, it's hard to pick what I'm going to say right here next out. But in this, when you put it in percentages, you can. So it's asking, in part B, we've just completed part A, we put the percentages in. Part B says, does the table in part A show a relationship between age and whether the students that ride the bus to school? And explain. And yes, it does show a relationship. And what I'm going to say yes. Yeah, yes. And why does it? Or how does it? Well, let's pick one. It shows us here that if you take the age groups, and I'm going to go with, I guess I'll just change to blue. If you go to the age group 12 to 13, 60% ride the bus. 14 and 15-year-olds, 48% ride the bus. And 16 and 17-year-olds, 40% ride the bus. So the first thing I can decide from here is that the older you are, older students are less likely or are not as likely to ride the bus. And we don't know why. Maybe it's because when you get 16 and 17, you've got your own car and you're driving to school, or you've got a friend with a car, or when you're 14 and 15-year-old, you have 16 and 17-year-old friends that have cars and you're riding with them. Who knows? Could be any reason. There'd be more questions that you could ask. Well, how do you get to school? You don't ride the bus. What do you ride? You ride in a car? Does your whatever? You get the picture? So that's the interpretation of that data. Okay, exercise 2, on your own. Directions. You randomly survey students in a school about whether they buy a school lunch or pack a lunch. Your results are shown. So there are 3 parts to this question. 1, they want you to make a two-way table that includes marginal frequencies. I've already drawn the table out. Okay, that makes it a little easier, I guess. B, it says for each grade level, what percentage of the students in the survey pack a lunch, buy a lunch at school, or buy a school lunch. Organize the results in a two-way table and explain what one of the entries represents. Okay, so we're going to combine. They made a two-way table that includes, here's the two-way table. Then we're going to find the percentage. I think what we should do is probably add in, organize the data according to the sheet here on the right, and then make room to put the percentage also in each column. That way you can You don't have to have two tables, but you can do it any way you want. I'm going to do it in one table when you return. And it says, does the table in part B, that's the table, the percentages part, does it show a relationship between grade level and lunch choice? And explain. So why don't you go ahead and do that. When you come back, I'll see if we can fill in some of this data and go from there. Okay, now that you're back, you've had time to look at this data. So the easy part is filling in the table, right? Grade 6 students. How many pack a lunch? Well, grade 6, pack a lunch. It says here on the table, in the sheet, it says 11 do. Okay, oh, I'm not writing very good here. Something is causing me to... Okay, let's try it again. I'm trying to write small, and I'm not really good at writing small when I'm in here. So 11, okay? And then it says in grade 7, how many pack a lunch? It's grade 7, 23. 23. How many in grade 8? 16. Okay? And then how many buy a lunch? Well, buy 9, buy, and 27, buy, and 14, buy. That's going by grade level, 6th, 7th, and 8th grade. Okay, so now there are 6 items in the table. We've added in the 6. We have the spots for the marginals. So I guess we should go ahead and now make a two-way table, include the marginal frequencies. So the marginal frequencies is if we go pack a lunch across 11 and 23 and 16, I think we're going to end up with 50. Okay, and for buy lunch, we have 9, 27, 14. Well, I think that comes out to 50 also. 50. And going down, we have 11, we have 20. 23 and 27 is 50. Right? 20 is 50. And 16 and 14 is 30. And when we add across, what do we get? 20, 50, and 30, we get 100. And 50 and 50 is 100. So I guess that is the table, and those are the marginal frequencies. Now for each grade level, what percentage of students in the survey pack a lunch and buy a lunch at school, right? So let's do the percentages. So 11 divided by 20, you take the 11 packing a lunch divided by the total lunch eaters, if you will, in 6th grade. And we're going to get, what's the percentage we're going to get? That's going to come out to be 55%. And then of the buyers or whatever, or the buyers, we're going to have 9 divided by 20, and that ends up being 45%. Okay? And then if we go over here to the 7th graders, 23 of 50 is 46%. And 27 of 50 is 54%. 54%. Now for the 8th graders, we have 11 out of 30. Oh no, at 16, I think it is. 16 out of 30. Sorry, that's not very clear, but I'm not going to touch it. 16 out of 30, and that gives us 53%. Okay, and buying the lunch, 14 out of 30 ends up being 47%. So if we look at this, what do we find? We find that, okay, so that explain what one of the entries represents. Well, I'll pick one. You could have picked yours, but if we pick the 6th graders, these entries say that over half pack a lunch, okay, and there's 55% pack it and 45 do not. So that's kind of what that's telling us, okay. And then and here, this is 100%, right? Because 55 and 45, 46 and 54 is 100%. We don't have to put this in here, by the way. I'm just doing it. And this is 100%. So 100%. And then if we look over here, we have 50 and 50. Okay. 50 buy and 50 do not buy. 50, right? So So for C, does the table in part B show a relationship to grade level and lunch choice? Well, if we look at it, I'm going to say no. And why do I say no? It's because if you look across, sixth graders, about half of them buy lunch. Seventh graders, about half of them buy lunch, a little less than half. Sixth graders, a little more than half. And eighth graders, a little more than half. Or a little less than half, not buy lunch, pack a lunch. So the buy lunch kids in sixth grade are a little less than half, or in seventh grade a little more than half, and in eighth grade are a little less than half. So when you get right down to it, there's no relationship. They're all about 50%. So there's no relationship.